Yes, good morning, students. This is Dr.J.Jaya, Associate Professor in AC Department, RMB Engineering College. I welcome to this video. Actually, in this video, I'm going to explain the topic board plot based problem. So this topic comes under the unit number 3. So directly we will move to the problem. So you see, draw board plot for the following transfer function. G of s is equal to 20 divided by s into 1 plus 3 into s into 1 plus 4 into s. Obtain gain crossover frequency. So here you have to find out your gain crossover frequency. The gain crossover frequency is represented by the symbol omega gc. So using a board plot, we have to find out the omega gc value for the given transfer function. Okay, so using board plot, this is very, very important. Okay, so first step in the board plot, you have to check whether g of s is in the standard form or not. So standard form is nothing but 1 divided by 1 plus s into t. That means 1 plus s into t. For example, you take one simple example, g of s is equal to 10 divided by s into s plus 2 into s plus 4. Now you tell me whether it is in the standard form. Definitely it is not in the standard form because we are having s plus 2 into s plus 4. So therefore, if they given the value like this now, then immediately you have to convert this into a standard form. After that, only you have to substitute s is equal to j omega. So that is the first step. You have to check whether g of s in the standard form or not. But you see in this problem, they given 20 divided by s into 1 plus 3 into s. Okay, similarly 1 plus 4 into s. So therefore g of s is given in the standard form. No need of any conversion. Okay, then after that already we are checked. So it is in the standard form. The next step, what is the next step now? Now we are going to substitute s is equal to j omega. So wherever we are having a s, so in that place we have to substitute j omega. So therefore g of s becomes g of j omega is equal to 20 divided by j omega into 1 plus 3 into j omega into 1 plus 4 into j omega. I'm substituted s is equal to j omega. Then after this, what is the third step now? You have to find out your corner frequency. Okay, so first 3 steps are very important. First thing, you have to check whether g of s is in standard form or not. Then after that, you have to substitute s is equal to j omega. Then next, you have to find out your corner frequency. The next very, very important thing is after calculating your corner frequency, how to arrange your corner frequency in the ascending order. That is very, very important. Okay. The next important thing is how to find out corner frequency. Ma'am, you are telling, then you have to find out corner. Then how to find out corner frequency? That is a big question. So how to find out your corner frequency value now? This is very simple. Real value divided by the coefficient of omega. That is imaginary part. Okay, so therefore we can substitute 1 divided by 3, 1 divided by 4. Okay, so 1 divided by 3 is nothing but what? 1 divided by 3 is nothing but 0.33 radian per second. The next 1 by 4 is nothing but 0.25 radian per second. Already I told you how to arrange your corner frequency in the ascending order. That's why here I am given omega C1. Maybe somebody having doubt why she is not given this is omega c1, this is omega c2. I told you you have to arrange your corner frequency in the ascending order. That's why I am given this is omega c1, this is omega c2. Okay, so therefore you are arranged your corner frequency. Okay, the next very important thing is if you are moving to board plot, then you have to draw two plot. One is magnitude plot, another one is phase plot. So for both the plot, the x-axis value remains same. X-axis is nothing but omega. That is the frequency value. Okay. And then y-axis only varies for both magnitude plot and the phase plot. So for that, for a magnitude plot, we are forming a table. So first column term, second column corner frequency, third column slope, then fourth column is change in slope. Okay. So first I'm going to take my first term. Now you see, so this is your first term, 20 divided by j omega. This is your first term. So for this first term, there is no corner frequency. What I told you, corner frequency, real part divided by imaginary part. But here there is no real part. So therefore there is no corner frequency. The next important thing is slope. Now you see 20 divided by j omega. That means the S term is present in the denominator. So if S term is present in the denominator, now the slope value is minus 20. Then next, there is no change in slope. The next time coming to the second term, 1 divided by 1 plus 4 into j omega. The corner frequency value is 1 divided by 4 is equal to 0.25. So here also we are having S in the denominator. So therefore minus 20. Then how to find out the change in slope? This is very important. The previous value, the previous slope value is added with the present slope value. So minus 20 you will get minus 40. Then next time coming to the third term, 1 divided by 1 plus 3 into j omega. The corner frequency value is 1 divided by 3 is equal to 0.33. So here also in the denominator only you are having a S term. So therefore minus 20. Then here how to write the change in slope means the previous slope value is minus 40. You have to take only this value. Okay. So this is the previous value minus 40. Then present value is minus 20. So minus 40 minus 20 you will get minus 60. Okay. Then after calculating this corner frequency, then after forming this table, what you have to do now? Then you have to assume two values. One is omega L. Omega L is nothing but low frequency. Omega H is nothing but high frequency. Then why we have to select this two value? Now? Then you see in the previous table we discussed how many frequencies are having? Only two frequency value. That is omega C1 and omega C2. Using these 2 points, it is very difficult to plot your magnitude plot. That's why we are taking two more points. One is omega L, that is low frequency. This low frequency value is always less than the omega C1. That is the first corner frequency. You have to select a value less than the first corner frequency. Okay. So that's why here I'm selected the value is 0.1. Then next one, omega H. Then omega H value, here I am selected the value is 1 radian per second. This is your choice. Okay, you can take any values, but the condition is the omega L value is less than your first corner frequency. Then omega H value is greater than the last frequency. That is the second frequency. That is omega C to the last frequency. Na, that value should be greater than. That is omega H value should be greater than the corner frequency value. That is second corner frequency value. Okay. Then after that, you have to find out your magnitude. Then how to find out your magnitude? Na? 20 log of modulus of first term. So first term is nothing but 20 divided by omega. So here we are substituting omega is equal to omega L. Omega L value is 0.1. So therefore, 20 log of 20 divided by 0.1, you will get 200. Then what you have to do now? Then you have to take 200 log. That is log 200. This is multiplied with 20. You will get 46.02. This is approximated to 46 dB. Then similarly, next thing, A is equal to 20 log of modulus value. That is the first term, 20 divided by omega. Here you have to substitute omega is equal to omega C1. Okay. So omega C1 value is, what is omega C1 value? 0.25. So therefore, after calculating the value, we are getting the amplitude value or magnitude value is approximately 38 dB. Okay. The next one, how to find out this amplitude value means A is equal to change in slope from omega C1 to omega C2 into log of omega C2 divided by omega C1 plus amplitude value or magnitude value at omega is equal to omega C1. This is standard formula to find out the magnitude. Okay, the change in slope from omega C1 to omega C2. Now you have to see this table. From omega C1 to omega C2, the change in slope value is minus 40. So therefore, minus 40 into log of omega C2 value is 0.33 divided by omega C1 value is 0.25. The previous magnitude value is 38. So that value only we are substituting here. Okay, so after simplification, we are getting the magnitude value is 33 dB. Then next, I am moving to the next magnitude calculation. So A is equal to change in slope from omega C2 to omega H into log omega H divided by omega C2 plus magnitude at omega is equal to omega C2. Then next important thing here, the change in slope is, now you see omega C2 to omega H, the change in slope is minus 60. So therefore, minus 60 into log of omega H value is 1 divided by omega C2 value is 0.33. The previous magnitude value is 33. So after simplifying, we are getting the magnitude value is 4 dB. So therefore, we are calculated the magnitude value. Okay. Then next I'm moving to the phase plot. So for that, I'm taking the expression g of j omega. So g of j omega is equal to 20 divided by j omega into 1 plus 3 into j omega into 1 plus 4 into j omega. So now you have to find out your phase. How to find out your phase? Tan inverse of b by a. So for example, a plus jb. For this number, how to find out the phase value? Na? Tan inverse of b by a. So here also same concept only. Now you see here there is no real term. So what is a b value? Omega. So omega divided by 0. Anything divided by 0, infinity. So therefore tan inverse of infinity 90 degrees. So that's why here 90 degree. Then next plus tan inverse of, then imaginary part is 3 into omega. So 3 omega divided by 1. Similarly, next term plus tan inverse of 4 omega divided by 1. That is b value divided by a value. Okay. So therefore, we can write pi is equal to. So this is present in the denominator. So I am bringing this in the numerator. So therefore, I am getting pi is equal to minus 90 degree minus tan inverse of 3 omega, then minus tan inverse of 4 omega. Okay. Then after this, we have to plot the phase plot. So for that, we are taking a different values of omega. Okay. So here you see 0.1, 0.2, 0.25, 0.3, 0.33, 0.51. For this different values of omega, so we are calculating the pi value using this formula. Okay. So therefore, for 0.1, we are getting the pi value as 129. For 0.2, we are getting 160. For 0.25, we are getting 172. That is minus 172. Here minus is missing. So here all the values are minus. Okay. Then similarly, 0.33, your value is minus 188. For 0.5, your value is minus 210. So for 1, your value is minus 238. So here all the values are negative values. Okay. Then now we know the magnitude values and phase values. So using this data, we have to construct the Bode plot. Okay. So this is a similar sheet. So using this sheet only, we are going to construct the Bode plot and phase plot. Now I am taking this is 0.01. Then next 0.01, 0.02, 0.03, 0.04, 0.05 like that. So this is 0.1. Similarly, 0.2, 0.3, 0.4, 0.6, 0.7. Then this is 1. Then next 2, 3, 4, 5 like that. So here 10, 20, 30, 40, 60, then 100. Then 200, 300, 400, 500 like that. Then this is 1000. So therefore, this is your x-axis. So x-axis value is omega, unit is radian per second. Okay. Then next, I'm going to mark my amplitude value. So here amplitude value is, actually what is the amplitude value we are getting? For omega L, 0.1 value 46 dB, 0.25 38 dB, then next 0.25, the next one 0.33. So 0.33 we are getting the value is 33 dB. Then next 0.1, 1. So 1 value, your magnitude value is 4 dB. All the values are positive. Okay. So therefore, so for a different values of omega, I mark the values. Okay. Then next, after that, what I have to do now, after marking the points, using a scale only, how to construct your magnitude plot. Okay. Then next important thing, here the phase angle value is negatives. The starting value is minus 128. So that's why here I am started minus 100, minus 150, minus 200, minus 250. For each and every omega value, I mark the phase angle value. So here I am getting the phase angle points. After that, using a freehand sketch, I joined all the values. Okay. Then next, after joining this, I mark this is phase plot, this is magnitude plot. Okay. Then next, how to find out this omega GC. So this is very important. How to find out this omega GC value. Na? Now you have to take your 0 dB line. You have to take 0 dB line. So that line will cut. See, magnitude plot at one particular frequency value, that is omega value. So that is your omega GC. So therefore your omega GC value is 1.15 radian per second. So this is a corner frequency value for this problem. I think this video is useful for you. Make use of it. Thank you for watching this video.